All right, hello everybody. Hope you've had a good weekend. It's beautiful outside. Hopefully you spent some time outside. Again, I don't know when you're watching this, but this work is due by Monday at midnight, so please make sure you get all your work done by Monday at midnight. Okay. I do want to point out a couple things. First of all, we are actually doing a lesson, which is not a typical thing. So please hang with me. It's going to be a good, decent chunk video, but I need you to follow along because it's a good practice and it's still skills you're going to need to know. You will also need a calculator for today's lesson. So please make sure, make sure you have a calculator because we are going to be using it throughout the lesson. Okay. Also on your homework, I am doing something a little different. I don't usually do this, but for problem 132, there are, I think, like 8 of them. You only need to pick 4. What 4 you do, I don't care, just as long as you do them and do them correctly. Please make sure you're writing the original problem and showing all of your work for all of these. You must show your work. So please write down the original problem, show your work, and the answer, okay? If you do not, I will just return it as incomplete if I do not see work. So make sure you have that work, okay? Let's begin here then. First of all, here's your homework from lesson 924. Please go ahead and pause the video and check your homework, okay? Please make sure you check it all. Make sure you have the correct work and the answers. If you have questions on this, unfortunately, you're not in class for me to ask, but you can send me a message or you can just talk to me on Tuesday and we'll go over some of this, okay? All right, so. Sorry, we have announcements going on, so I'm just going to try to talk over him. All right. So pause it when you're done, and we'll keep going. Okay, let's go on to today's lesson 925. How can I find missing parts? Applications of the Pythagorean theorem. Now, we've been working with the Pythagorean theorem again. That states a squared plus b squared equals c squared. But we're going to apply it, give it some word problems that we'll be using it. In this section, you have studied different properties of triangles. You have used the Pythagorean theorem to describe the special relationship between the sides of a right triangle. In this lesson, you will use these ideas to solve a variety of different problems. A lot of these problems, some of them I'm going to skip because we're doing video. If we were in class, I'd do them, but we're going to skip some of them. We're going to shorten some of them, but the ones that we do, I do want you to follow along, show your work, everything you do, and make sure that you write it on your paper. Problem 922. Anne is measuring some fabric pieces for a quilt. Use the Pythagorean theorem and your calculator to help her find each of the missing lengths below. Decide whether each answer is rational or irrational. If it is rational, explain whether the decimal repeats or terminates. Remember what rational means. Rational numbers are numbers that repeat or terminate. Irrational don't, like pi, okay? So you're doing 2 parts. You're finding the missing side, and you're telling me if it's rational or irrational. If it is rational, you're saying how you know, okay? Now, I'm going to do the first one for you. You're going to do the second one, okay? If you think you can do the first one on your own, you're welcome to pause the video or mute me and do it on your own, and then compare. Just don't forget to unmute when you're done, okay? A squared plus b squared equals c squared. Where c is your hypotenuse, and in this case, we're missing c, so just be aware of that. So I go here, 32 squared plus 24 squared, and again, it doesn't matter which one you put as a and which one you put as b. I really don't care as long as you have them both pretty much lined up like that, okay? So let me get my calculator here. 32 squared is 1,024. Plus 24 squared, which is 576, equals c squared. Then you add those up, and you get 1,600, nice, easy number, equals c squared. And then at that point, how do I get the c alone? To get the c alone, you have to square root both sides. And when you square root c squared, it ends up with just c. And the square root of 1,600 is 40. So my answer here is 40 inches. Okay? Now, don't you dare just stop there, right? Because that's only half the answer. This other part said whether it's rational or irrational. In this case, this answer is rational because it terminates. It does have an ending, therefore it's rational. Okay? All right, so now I do want you to pause the video. And I want you to try B on your own, showing your work. Okay? When you are completely finished with B, please unpause the video, and then we'll see if you got it right. Okay, so let's check your work. So I've got, again, a squared plus b squared equals c squared. A, I'm going to put 10, so 10 squared. B, well, be careful here. This is across from the right angle, so therefore this is your hypotenuse. I do not know b, so I'm just going to put b squared equals c squared, which is 20 squared. And you could have switched this. You could have had a squared plus 10 squared. So the 10 doesn't matter if it's a or b, as long as it's one of those. And this is your hypotenuse, and you've got to have it in for c. So then I get 100 plus b squared equals 2 squared is 400, or 20 squared is 400. Then I subtract 100 because I'm wanting to get the b alone, so subtract 100, and I get b squared equals 300. Then again, to get the b alone, I have to square root both sides. Square root both sides. And when I square root 300, I get that b equals 17.32 ... That's what I should have gotten if I'm rounding to the nearest hundredth, okay? So that's my answer, 17 and 3,200 meters. Tell me you didn't finish there, right? Because we have to say if it's rational or irrational. This is irrational because the answer you should have gotten in your calculator was, oh, it cleared for me. Hold on a second. There we go, 17.320500808. Now, you could argue that at the end it seemed like it was repeating, but we just didn't have all the information at the end, so therefore we can assume it's probably irrational. Hopefully these make sense. What I want to tell you is I want you to look at the screen and I want you to see it. And I wish you could remember at the beginning of the year, if you had seen this at the beginning of the year and said that you would be able to understand this, that is just so crazy. Look at how far you've come. Look at how much you've learned, that you can see this and understand it and do it on your own. I love that, okay? Let's practice another problem here. Baseball players, those of you who like baseball. Those of you who don't worry, you can still solve this. Coach Kelly's third period PE class is playing baseball. The distance between each base on the baseball diamond is 90 feet. Lisa at third base, which is here for those of you non-baseball people, throws the ball to Dano at first base, which is over here. How far did she throw the ball? State whether your answer is rational or irrational. So I would really love it if you could try this problem on your own. Now, it doesn't mean you have to get it right, but I want you to try. If you get stuck, you're welcome to unpause the video until you get to the point where you're like, oh, okay, I get it. And then I want you to keep trying on your own. The goal, of course, of all of these is that you try to do the work on your own. Use me to help you when you get stuck. So begin, please. Pause the video. See how far you can go. All right, let's see what we have here. Now it says that the distance between each base is 90 feet. So I know this right here for all of them is 90 feet. It's like a square, right? However, she throws from third base to first base, which would imply right there, cutting across. So if I took that picture out, if you can picture it, I'm going to turn it a little bit even. Oh, let's not turn it. Let's put it exactly how it would look. So I would have something like this. Here's third base. Here's first base. Throw across. I know this is 90 feet. And I know this is 90 feet. And since it's a baseball diamond, which is a square, that means this is a right angle. So therefore, I'm finding this missing side here. So I'm going to use Pythagorean theorem. A squared plus b squared equals c squared. These two, what do I have? Do I have two legs or do I have a leg and hypotenuse? Well, since the right angle's here and the legs are always touching the right angle, I know that this is your hypotenuse. This is letter C. So I have 90 squared plus 90 squared equals c squared. And once you get to this point, hopefully you see, once you set up your Pythagorean theorem, it's the same process again and again and again. There's really nothing new once you get to this point right here. It's just a matter of getting comfortable with getting to this point. 90 squared is 8,100 plus 90 squared is 8,100 equals c squared. Now at this point you might be like, oh, well, then the answer C is 81 or 8,100, right? No, because we're adding these, okay? Please remember, squaring something does not mean times 2, it means times itself, okay? So when I add those up, I get 16,200 equals c squared. And then you know what to do, right? You find the square root of 16,200 and your answer, square root, let me show it. Your answer is C equals approximately, you can even do this, which is kind of cool. When it's not exact, you can go approximate 127 point what? If you're on to the nearest hundredth, 28. Because even though it's 27, the number after the 7 is a 9, which would round that 7 up to an 8. And that would be my answer right there. Although some would argue that's technically wrong, right? Because it should be 127 and 2/8 feet. That is a true answer. And tell me you didn't stop there. Because I had a second part. Is that rational or irrational? It is irrational because it kept on going. It did not terminate. It did not repeat. Okay. We're not going to do too much more. Here we go. Stick with me here, please. Now, this one's a little unique. As a planner, as a city planner of Wright City, you are responsible to report information to help the Board of Supervisors make decisions about the budgets for the fire and police departments. The board has asked you to report with answers to the following questions. Each grid unit in the figure at right represents 1 mile. So imagine all of these are just 1 mile, 1 mile, 1 mile, 1 mile, 1 mile, 1 mile. Every single square here is worth, or unit of the square is 1 mile. A, for fire safety, bushes will be cleared along the perimeter of the city. And this is Wright City right here. This is the city. And yes, it's kind of weird. Who shapes a city like that? I don't know, but someone did. So, oh, that's not my eraser. The bushes will be cleared along the perimeter of the city. What is the length of the perimeter? Include all your calculations in your report. We're probably just going to do this one step. So here it is, right here. Okay. If you did have graph paper, it wouldn't be a bad idea to have this on graph paper. I don't have a handout for you on this, but just go along with me here, okay? Try to figure out what we're going to do here. Let's start with the easy side. If this is a perimeter of my city, how long would this side be here if every square is 1 mile? Well, here's 1, 2, 3, 4, 5, 6. Awesome. This side here is 6 miles. Now I've got to find some of the other sides here, right? What side? Well, let's go with this red side here. Now, it is a diagonal. Diagonals are really hard to find. In fact, we can't really. Now, if we were there, we maybe could measure it with some way, like a car or something, but we can't. So from here, what do I have to do? It's very similar to the work we did in class, where if you turn this into a triangle with a right angle here, now I've made a right triangle. Now I can find this side using this. And as you notice right here, this is your hypotenuse. So I just look at 2 sides here. This side here is 3. This one is 1, 2, 3, 4. So I've got, I use my Pythagorean theorem, a squared plus b squared equals c squared. Write this down. If one of the sides is a, 3 squared, plus the other leg is 4. 4 squared equals c squared. 3 squared is 9. 4 squared is 16. And if I'm going too fast, please pause. Please pause. And 9 plus 16 is 25 equals c squared. Find the square root. Awesome. My missing side is 5. So this side right here, the red side, is 5. Now, on your own, please find the length of the green side. Your task, find the length of the green side. Pause the video, find it, show it, and then unpause when you're done. All right. Well, once again, I make a triangle here like that. It's a right triangle, meaning this is your hypotenuse again. This side here is 2, this side is 3. So I go a squared plus b squared equals c squared. 2 squared plus 3 squared equals c squared. 2 squared is 4. 3 squared is 9. 9 plus 4 is 13 equals c squared. Is that going to be a nice even number? No, it is not. It is going to be kind of ugly. Let me get my calculator. And the square root of 13, is 3.61. It's approximately the area of C. Okay. Now, do you see how I did this approximate symbol? Again, from now on, when you round, I really kind of want you to put that symbol because it's not exact. So if I'm trying to find the perimeter, this is my green side here. If I'm trying to find my perimeter, I would add up all the sides. I've got 6 and 5 and 3 and 6100ths. So 3 and 6100ths plus 5 plus 6. The perimeter of the city is 14 and 6100ths miles. And label that. That's a perimeter. Perimeter, 14.61 miles. And I think the question said, is it going to be irrational or irrational number? And the correct answer is that would, of course, be, it would be irrational because this number here continued on. This number was irrational, so when I add it, of course, it's going to be irrational in the end. Okay. All right, that was a lot. We're going to skip that problem. Last thing we're going to do is problem 126. You're with me so far. If you need to take a break, mental break, you can take a mental break, come back and finish watching it. This is the last problem we're going to do. However, it's really good practice. Scott and Mark are rock climbing. Have you ever rock climbed? I have. It's kind of scary, depending on how big the rock is, of course. Scott is on top of a 75-foot cliff. Okay, that would be scary. When he throws a 96-foot rope down to Mark, who is on the ground. Listen carefully to this. Let me say it again. Scott is on top of the 75-foot cliff when he throws a 96-foot rope down to Mark, who is at the ground below. If the rope is stretched tightly from Mark's feet to Scott's feet, how far from the base of the cliff, directly below Scott, is Mark standing? Draw a diagram and label it, then find the missing length. Is the length irrational? All right, here's what I want you to do. I want you to pause the video and try to sketch this diagram on your paper. Reread the paragraph if you need to. Take some time if you need to. It's really important that you visualize what it would look like and then draw it. Once you've drawn it, unpause it, and we'll check that. And then if you're right, find the missing length. If you're wrong, change it, and then we'll find the missing length. Got it? Go. All right, so hopefully you've already got it drawn. Ready? Here is my wonderful cliff. Woohoo! And here is Scott, my very artistic stick figure. That's all I do. And it says the cliff is 75 feet. So this right here is 75 feet. He throws a 96-foot rope. Now here's the thing. When you throw the rope, yes, he might throw it down like that, but then it said it got stretched out as far as possible. So what we're doing here is we're saying, hey, you know what? And it's not even necessarily in his hand. We are going to go from the base. So maybe he threw the rope, but then he just kind of tied it here. And when you tie it and it's going down, it'll just go to the very end. And it's stretched out 90. Now, here's the ground. It's stretched out this way 96 feet. Because here is Mark, all the way at the bottom. And why hard this? There we go. Okay, cool. That's, I don't know. All right, so here's Mark. Yoo-hoo! Now, technically, probably 96 feet. He would be a lot smaller. He would probably be, because, yeah. But anyway, we're working here. And the question is, how far from the base of the mountain is he standing? Well, based on this diagram, is this a right triangle? Well, it should be. And right here, straight down from the cliff, we're assuming the cliff is straight down. That's usually what cliffs are. Across, it makes a right angle. Now, yes, I know that's an assumption. It's assumption, but work with me here. Now, please find the missing side. Go. Make sure you show your work. Use your calculator. Do Do all the things you need to do. When you're done, unpause it. All right, one last time. A squared plus B squared equals C squared. Are you sick of writing this down? I don't know. A. Let's leave A alone this time. Let's put A squared plus, what is B? B is 75. Remember, C is your hypotenuse. So that one's going to go over there. So plus 75 squared equals 96 squared. I need my calculator because I don't know those numbers in my head. Okay? And here we go. A squared plus 75 squared is 5,625. 96 squared is 9,216. Then, how do I finish solving this? I want to get A alone, so I subtract 5,625 from both sides, and I get that A squared equals 5,625 equals 3,591. Finish it off. I square root both sides. And A, well, what is A? Let's see. Oh, I need to put the approximate symbol, right? Because I'd get 59.92 ... Because this answer, is it rational or irrational? This answer is irrational. You wrote that down. Please, please, please make sure you're reading the question and don't forget to put that. So 59.92 feet. There it is. Got it? Awesome. I hope that makes sense. I hope you're good and you're clear with that. Math notes box is right there. If you have some questions about squaring and square root, please read that. It is there. I'm not going to read it for you because my voice is killing me already. So finish that up. Do the homework. The homework, again, I put for 132, I said you only had to do 4 problems. We'll see who watches the video, because if you didn't watch the video, you're not going to get that. And you are going to do all of them, aren't you? That's the cost of not watching the video today. So if you watch the video, you know you have to do less work on that problem. So finish reading the math notes box. When you're done, you may go ahead and stop and be done. Have a wonderful day, and I will see you on Tuesday.